Muy buenos días a todos y bienvenidos a esta tercera sesión del ciclo virtual Infraestructura Sostenible, Resiliencia y Certificación para un Futuro Responsable, una iniciativa de la Cámara Colombiana del Cemento y el Concreto, PROCEMCO, que busca abrir espacios de formación y reflexión sobre cómo construir infraestructura más duradera, responsable y adaptada a los desafíos actuales del país y del planeta. Somos PROCEMCO, la Cámara Colombiana del Cemento y el Concreto. Desde nuestro centro de formación, impulsamos el uso adecuado y responsable del cemento, el concreto y los prefabricados, promoviendo la actualización permanente del sector construcción en tecnologías, soluciones innovadoras y prácticas que garanticen sostenibilidad, calidad y durabilidad en los proyectos. Ahora en Procemco tenemos una forma rápida y fácil de mantenernos conectados, nuestro canal de WhatsApp. Allí podrás estar al día con eventos, conferencias, capacitaciones y enterarte de las últimas novedades del sector del cemento y concreto en Colombia. Suscríbete ya mismo. Solo debes hacer clic en el enlace que estamos compartiendo en el chat o escaneando el QR que aparece en pantalla en este momento. Noticreto es la revista de Procemco sobre innovación, tecnología y buenas prácticas en construcción de concreto. Por solo 36.000 pesos colombianos o $14 al año, disfruta acceso ilimitado a noticreto.com y a contenidos exclusivos para suscriptores. Suscríbete escaneando el código QR de la imagen o ingresando a los enlaces que estamos poniendo en el chat. Elige si estás en Colombia o fuera del país. Aprende, inspírate y actualízate con cada edición de la revista Noticreto. Estamos en el ciclo internacional Infraestructura Sostenible, Resiliencia y Certificación para un Futuro Responsable. Está compuesto por 4 conferencias impartidas por reconocidos expertos, quienes abordarán la sostenibilidad en infraestructura desde diferentes perspectivas. Iniciamos con el enfoque de resiliencia frente a los retos climáticos y de durabilidad. Continuamos con la importancia de la legalidad y la trazabilidad como pilares de una sostenibilidad real y hoy tendremos una mirada técnica sobre los pavimentos de concreto sostenible. Tendremos esta tercera conferencia y para presentarnos este tema nos acompañará Thomas Van Damme desde Michigan, Estados Unidos. Y como les anunciamos, esta conferencia será dictada en inglés, no tendrá traducción simultánea, pero sí subtítulos en tiempo real generados por IA. Y a continuación voy a presentarles a nuestro conferencista de hoy. Él es Thomas Van Damme, ingeniero civil con más de 39 años de experiencia en materiales de concreto, en sostenibilidad, resiliencia y evaluación integral. Sus áreas de especialización incluyen durabilidad de pavimentos y losas, investigaciones forenses y la reducción de gases efecto invernadero. Ha dirigido numerosos estudios de diseño, análisis de costo de ciclo de vida y estudios comparativos de concreto con bajas emisiones de carbono, incluyendo maquetas a escala real con más de 100 publicaciones. Ha colaborado en proyectos de investigación exitosos para agencias federales, departamentos de transporte estatales y la industria privada desde el 2023 pertenece a WJE. Quisiera también aclararles que para la sesión de preguntas lo manejamos igual que siempre, solo que vamos a tener una persona apoyándonos traduciendo sus preguntas al inglés para que nuestro conferencista pueda resolver sus inquietudes. Y bueno, sin más preámbulos, le vamos a dar la bienvenida a nuestro conferencista Thomas. Hi Thomas, good morning, how are you?
Buenos días.
Buenos días, ¿cómo estás?
Uh, so.
Welcome to this space. You can share your screen, please.
Is
Okay.
it okay?
Okay, can you see to you? Can you see your presentation?
It is good for me.
Okay, let's go. And we can see you at the end for the questions.
Excellent. Thank you so much.
Okay.
Yeah. Lo siento, no hablo español. I have been wanting to learn Spanish for many years, and I must do it. My wife speaks Spanish, and I always rely on her when I visit places like Colombia. So I will have to become better. Thank you, all of you, for being here. Today, I'm going to present work that I was involved with for the U.S. Federal Highway Administration, where we worked with numerous state DOT agencies in the United States and got their input. I will talk about pavement resilience in general and present why we care and the results of our work with federal highways. I'll talk about some broader initiatives and how we need to integrate resilience in with our asset management systems. And then I'll close with talking about some strategies specifically to work with cement and concrete to improve the resilience of pavements. Now, there are many resources that you can download. In the United States, we are having, let's just say, a difficult time these days. So some of the publications that we have worked on in the past are no longer directly available. But if you search by title, you will still find them. So they are no longer on the Federal Highways website, but they are still available on the web. So you will get this presentation, so you'll be able to download these resources to help. I will start by talking about the relationship between sustainability and resilience. Sustainability is there to seek solutions that avoid changes that will impact people and the environment. So when we work on sustainable solutions, we're trying to prevent bad things from happening. Resilience is related to that, but it's really how do we bring about strategies that will help us endure and survive those impacts. So when an impact such as just happened this week with Hurricane Melissa struck Jamaica, many people think this is related to climate change, the immensity of that storm. What resilience is about is building our infrastructure to resist the damage and then quickly get back and serve people. Now, this is a hippie holding a sign. This was something common in the United States in the 1960s. And the hippie sign says, "The end is near," and you can see this hippie is getting very old. But the individual is asking, can you be more specific? What end is near? So I'm going to talk about climate change and resilience. Some people do not believe that the climate is changing, but it certainly is. The Arctic is melting, temperatures of the ocean is rising, sea levels are rising. We're seeing flooding events are increasing in both frequency and magnitude, and hurricanes such as we've just seen in Jamaica are becoming much larger and more intense. So when we design our infrastructure, we must design it for this changing environment. And that is really what resiliency is about. And this is a worldwide effort. This is a report by the World Bank. Maybe some of you have seen it. This is specifically on Colombia. Again, this is a document that you can download. And I just have pulled a few figures from it to illustrate what the anticipation is for your climate change in Colombia. And you can see up till about 2050, maybe the changes are somewhat mild, maybe a couple of degrees centigrade. But by 2100, we're going to be seeing some immense changes in temperatures. Now, these changes are not the same everywhere, but they are overall rising. The changes in precipitation, on the other hand, are variable. You will see some areas are going to get much more rain. Other areas will be getting less rain. So this is something that we will have to adapt to. Many people want to paint a broad picture and think that the trends are the same everywhere, but they are really quite regionalized and something that we're going to have to account for. So this FHWA peer exchange that we completed a few years ago was really interviewing different DOTs about the impacts of the climate change on pavement. So I will start with the results of that study. The number one issue identified throughout the United States was flooding. So many people think about temperature as being the big change, and that's going to have the biggest impact on, I think, the health of individuals. But from the infrastructure's perspective, it's going to be flooding. We're going to see increasing coastal flooding due to sea level rise, so that even when it's sunny out, when we have certain tides, roadways will flood that did not flood before. We're going to see coastal flooding when we have big storm events, again, such as we just saw in Jamaica. We're going to see increased flooding of rivers that flow into the sea, because as sea level rises, it kind of dams up those rivers. And we're going to see a lot of riverine flooding. Rivers will flood inland due to high intensity storms that we have not witnessed in the past. Other issues that are related to flooding is there's a lot of uncertainty that now a pavement has flooded. When can we open it back up to traffic? Because we need to get in very quickly to bring in aid and restore service. But when a road is flooded, a lot of damage will occur, and I'll talk about that more so towards the end. So just the fact that the road is getting wet is raising its chance of it being damaged by vehicles. Then there's this high velocity water flow. This issue is not one that we can handle with a pavement issue alone, but this is where roadways erode and they wash out. So it's a related issue, but one that as a pavement designer, we cannot really affect. That's really up to drainage and how do we handle that. In the ideal world, if a pavement floods, we just all wait, we get out of our vehicles, we walk the dog, we have a good time waiting for it to dry. But that's not reality, right? The reality is that we have to use roadways. They're necessary for health, they're necessary for safety, they're necessary for our economic well-being. And so we will drive on these roadways as quickly as we can, sometimes while they are still flooded. Non-flooding related issues that were also identified by these group of state agency people is that temperature is a factor. It will affect some pavement materials more than others. We know the pavement material most affected is asphalt, whereas concrete pavements are relatively unaffected by rising temperatures. We also need to do risk analysis and prioritization to identify the pavements that are going to be most in need of improved resilience. And I'll talk more about that a little bit later. And then this idea of rapid response strategies. How can we know that the pavements are going to be safe to drive on without damage so that we can restore pavement operations and allow them to be used again to support our society? So when they started looking at techniques specific to deal with the climate, again, the first thing everybody focused on was flooding and inundation. That's just when the flooding doesn't have to be a flow of a river. It can just be a rising water table. So one of the first things people talked about is, well, why don't we make the roads higher? We can simply raise the elevation of roadways. But that can have very negative impacts if we don't consider that if we raise a roadway, we're effectively creating a dam. And so we may be damming surface water that would normally flow across the pavement and then causing more severe flooding. Some instances in the United States, agencies have gone to building causeways or very, very long bridges through areas that have been threatened by continued flooding. But that is very, very expensive. Another strategy has been armoring roadways to make them less susceptible to erosion when overtopping occurs. And so often we might not put paved shoulders on our roads. We might not prevent the erosion of embankments that don't normally see flooding. And this may become necessary. And then several agencies in the US are now starting to use subgrade and base stabilization. This is where we treat these unbound materials with cement most often to make them moisture intolerant and keep them from becoming weak when they get flooded. One of the big ones that's most attractive to the concrete industry is to use the stiffer and or thicker surfaces. And our rigid pavements, another word for concrete pavements, they, as I'll talk about a little bit later, they distribute the load much better than does asphalt pavements, and therefore are most often more resilient when flooded than the asphalt pavements. So this is really the focal point, I think, of a lot of the efforts, is why concrete can be attractive as a new construction material and also using concrete overlays over asphalt to make those asphalt roadways more resilient. Another thing that was talked about is more robust pavement drainage, try to facilitate the rapid removal of moisture from not only the surface, but the subsurface of the pavement. This includes the use of geosynthetic materials and permeable pavement systems. So that's another technique that was looked at. And the final one was really looking at how do we know when it's safe or we can minimize the damage to the pavement before we open it to traffic. And there's something like a falling weight deflectometer and doing structural assessment has really gained a lot of popularity, where you can get out, you can test and say, yes, we are ready to open. The problem is for many of these unbound pavement layers that are not drainable, they can take weeks and even months to gain structural capacity. So we really need, again, to focus on making these structures more resilient. Things to address temperature. Basically, concrete pavements are relatively insensitive. So there are, I'll talk a little bit about a risk of concrete pavements coming up, but in general, concrete is a very resilient material. When building with asphalt, there's a whole lot of things that DOTs are looking at. They are polymerizing their binders, they're building thicker layers, they are moving towards what's called balanced mix design. This is a concrete presentation, so I won't spend much time talking about the asphalt, but there's a lot of efforts to try to make the asphalt more resilient. One other thing that is becoming common, though, is we're moving more and more of our construction to nighttime to get away from the heat of the day for the sake of the workers. So when we're addressing design deficiencies, current pavement design methods that we use are typically, they're not accounting for the changing climate. They're not accounting for the level of flooding, inundation that will occur, and they're to a lesser degree not accounting for temperature increases. So tools need to be developed to help agencies better design for the coming changes in climate. This theme keeps coming up again. I'm going through what the agency people said, but we have to identify more moisture resistant supporting layers. So again, moving towards that stabilization, increasing permeability and drainage, and then thicker pavement structures than we have designed in the past. A really important thing that was pointed out, though, is we have to do a better job of tracking flooding data, and we have to identify how it's affecting our pavements. This is kind of going to create a recalibration of our design models so that we spend the time to understand these impacts and establish and use design, construction, maintenance, and emergency repair protocols for those identified pavements. There is a need for further evaluation of pavement design models. And so there's a broad feeling that what we have done in the past is not necessarily going to be adequate for what's going to be happening in the future. And so a lot of efforts are going to be expended here. So the final thing that was brought to the peer exchange groups was how do we approach improving the resiliency of our network? So when we look at a network, there are 5 steps that were really looked at. The first is understand site context and the future climate. The second is evaluate the pavement against future climate scenarios. The third, develop, evaluate, and select adaptation measures. The fourth, review additional considerations. And then the fifth, monitor and revisit or revise as needed. And I will go through each of those in a little bit more detail. So understanding site context and future climate is really, I think, the first key step. So it's to look at your pavement network and calculate and determine what are those critical links in your network. Our networks consist of a series of highways to local roads. It's not just how much traffic it carries, but you have to look at the impact if that link is removed from our network. So what is the impact on people? What is the impact on commerce? Can we get food from the markets to the cities? Can people get to hospitals? What is the impact if we lose that link, and how do we adapt? So a very broad analysis of the network to identify the high value links is critical. Once we identify those links, then we look at our projection future climate and see how they would affect that link. As I mentioned, temperature is not the focus here. It's looking at flooding. So it's really looking at where within our network we expect flooding to occur in the short term and the intermediate term. So we identify, okay, these are our links. Here's where the flooding's occurring. Then we look at the pavement data for those critical links that are going to potentially be at risk. And from that, we determine if they're vulnerable. What type of materials are they built out of? How thick are they? What's their elevation? And then we can really get into that specific climate data and find this key data is often available from universities or from the various environmental agencies that countries have. And then we look at how that will really affect at a very local level. And so you can see how a city, let's say Cartagena and that area around there, they could really focus in on what links would be really critical if we start to see more storms. I know that you do not see many hurricanes in Colombia, but that may change potentially. And actually looking at the map, it looks like your precip is going to become much more significant on the West Coast than the Caribbean side, the Pacific side. So those are the things that would be studied. Once we have that basic data, then we really start to evaluate our pavement links against those future climate scenarios. And we try to identify those areas that are really have the highest likelihood of being impacted, and also if the consequence of that link being taken out of service is most severe. So this analysis, again, is done on a network level. You identify probability and cost of predicted impacts. And alternatively, we can calculate, using modeling. And so I think this is a very interesting thing to study, and we really need to do more of it. Once we do that, now we have to consider all the possible solutions to address the limitations that we've observed. So here we're developing, evaluating, and selecting adaptive measures. So often agencies have their mix of fixes, we would say in English, which would mean they have a very short list of potential repair strategies for damage that they see. And here's the time to broaden that and look at fixes that you maybe did not consider before. It's also important to do studies to look at what has been done by others, what has been found to be effective. We're talking predominantly Colombia, other South American countries here, but you can look at what's maybe been done in North America. You can look at what's been done in Africa or other places, Asia, that might work. Evaluate feasibility of actions. So here we're assessing the efficacy of your possible actions under those future climatic scenarios. So you may see that we have a lot of asphalt roads that are not going to do very well if flooded, that have never been flooded or have only seen flooding rarely. What can we do to those that that is feasible to make them more resilient? Start really prioritizing to implement those most feasible actions and then implement them. And the implementation starts now, where you start to bring those solutions into your asset management systems. So as we start moving along, we're going to be collecting now. We got to look at other considerations. So there could be things beyond just what we talked about that may really make a difference. And for example, if it's a highway to the presidential house, that might all of a sudden become a high priority to keep that in good condition. And then finally is as we start to build these considerations into our asset management systems, we include now climate vulnerability as a factor. We analyze data, we do a better job of predicting long-term changes, And then we developed treatment matrix specifically to make pavements more resilient. And right now, we likely are not doing that. So it may make it so that we have to add additional treatments or rehabilitation strategies for our pavements that we currently don't do. So specifically, how can we use cement and concrete to improve pavement resilience? This illustration is complicated. I got this from a close colleague of mine. His name is Jim Mack. He used to be with Cemex. Some of you may have seen Jim speak. He now works with me with Shani Elsener, so I'm very excited about that. Jim likes to put a lot of words on his slides, and later they're good to look at. But the bottom line from this is if we look at asphalt pavements, they don't spread the load out very well. Asphalt pavements are designed as a layered system that is going to be heavily dependent on the underlying subgrade, which we then protect with a granular subbase, which we then protect with a granular base typically, that we then surface with asphalt. So each of those layers is heavily dependent on the other to protect the underlying layer. The load is more concentrated. We see higher deflections. We see higher stress in those underlying layers, and we need more layers. Concrete, on the other hand, carries the load through bending. And so as such, it really distributes that load out much more so than an asphalt pavement would. This reduces the stress and deflection on those supporting layers, and it really is a different philosophy on how to carry load. One note that is at the bottom there is the pavements are designed really for optimal moisture conditions and density. And our fine-grained soils typically, if they have a lot of, let's say even above 5 or 6%, passing the number 200 sieves. So I think that's the 0.75 millimeter. Please don't quote me on that. My metric is not as good as it should be. But regardless, the very finest particles, if they have that in those layers, they just don't drain. So what happens when those layers get flooded, the asphalt pavements are going to really have a reduction in their ability to carry load. They will suffer fairly dramatic failure if they are saturated. The load carrying capacity reduction can even last over a year if there's not good drainage built in. And during those times, the pavement is getting accelerated damage. Concrete pavements, on the other hand, are able to maintain a very high level of strength and stiffness. The subgrade is weak, but still uniform. So concrete will spread that load out. And even though some damage will occur, it will be to a far lesser degree. Now, this is an illustration. This is from the state of Florida in the United States. The reference is there under sources. You won't be able to read it, but if again you download this presentation, it's available to you. And what they found in this case, even over a year, they still lost the structural capacity of that pavement. So the flooding event itself may have only lasted a few days, but once that system got saturated, once the groundwater rose up, they could not dry it out. And for this particular case, they lost 40 to 60% of their strength, of their load carrying capacity for a period of over, which resulted in really about a 3-year loss of life. So fairly dramatic. These are examples from Houston, Texas that were concrete. And you could see on I-10 and 288 Texas, these are very major roadways. They have actually now been flooded multiple times due to hurricanes. And they opened the roadways up immediately after the water receded. And they have found, again, it's published information, it's listed at the bottom there, that basically very little to no damage was realized. So these are real life, excellent illustrations of how concrete is a more resilient choice. Some other opportunities, so that is if you build out of concrete new. If you are going to use asphalt though still, there's a tremendous opportunity to use cement for stabilization. So in these cases, you can have soils that would be very susceptible to loss in structural capacity if saturated. These can be treated with cement to effectively desensitize those and keep them maintaining their load carrying capacity even if saturated. Concrete pavements for critical pavement links, that are expected to be inundated, really should be prioritized and stabilize not only the subgrade but also the base, and consider that if they're not going to build with concrete. The other thing is we have a lot of asphalt pavements out there that we will identify are critical links that will be subjected to flooding. And recognizing that, a great alternative is to overlay them with concrete. These concrete overlays might be 150 millimeters thick. They could even be, as thin as 100 millimeters thick, but they will have been found to be able to spread the load out. So we could have an asphalt pavement that could be subjected or at risk. We could come in with a concrete overlay, relatively thin, and that will significantly improve the resilience of that pavement. And it does that, again, by that same load spreading phenomena. So it's not a need to reconstruct the road. It's strictly placing concrete on top. Typically, we are placing these now at 150 millimeters thick, and the slabs are, well, they're 6 foot by 6 foot, so roughly 2 meters by 2 meters. I think it's 1.8 meters by 1.8 meters slab sizes. And these have significant ability to improve the load carrying capacity when flooded. Now, there are concerns also, as we mentioned, with temperature. The big one on asphalt, of course, is that asphalt is a viscoelastic material that is quite sensitive to increasing temperatures. The asphalt binder becomes far less viscous and starts to flow, and this leads to rutting and shoving. If the layers become also flooded, this becomes even worse. So, as we mentioned, concrete is relatively insensitive to temperature, but the problem that we have been suffering in the United States is some of our older concrete pavements where we have not maintained the joints, we have not kept the joints cleaned and sealed. When it gets really hot and it's really humid, a lot of moisture in the air, that concrete will swell and to the point that the joints cannot accommodate that movement. And we get a phenomenon called blowups. So these blowups we've been seeing them most dramatically in the late spring when there's still a lot of moisture here. And all of a sudden we get big temperature spikes that we haven't seen in the past. And they can be fairly dramatic. So this really does speak to the need to have good design elements and good maintenance practices on concrete to avoid blowups from occurring. So to conclude, the conversation on resilience is driven by climate change. What has happened in the past is not necessarily what's going to happen in the future, and I would even say most certainly will not. So we have to really understand that things are changing. So resilience is this practice of implementing strategies now to endure and rapidly recover from the impacts of this change. So make things more resilient to resist changes and requires long-term planning and good decision making. I know that, for Colombia, your government officials are always making good decisions, but we are suffering a little bit here in the United States right now. So hopefully, luckily, a lot of the state agencies are still operating in doing good decision making. And that was a joke, just so you know. Concrete pavements are also a very resilient choice for the reasons I discussed. They're exceptionally good to deal with inundation and flooding because of their load spreading capability, and roadways can be kept open even if flooded. And concrete overlays of asphalt are really, really an excellent choice if your road network is predominantly asphalt pavements and you need to immediately improve the resilience of some links. We talked about the 5 specific approaches. I think this is a very exciting area because there's a lot of opportunity here to learn and then apply what we have learned and integrate it, and then monitor and tweak and make it, improve it. And cement and concrete have a very positive role to play in improving pavement resilience. So maybe that same hippie now has become very old. He's still holding his sign, the end is near, but actually we're really at an exciting time. It's a new beginning. And although we have a somewhat of a scary future maybe ahead of us, I think there are also many positive things. And in my trips to Colombia, what I always loved was how smart and educated the young people were. I don't know how many young people are on this call. I do know that the folks I've talked to so far were young people. And it's always to me so exciting to see how inquisitive and educated Colombians are. And so therefore, I think a very bright future awaits you. And so with that, I would be ready for questions.
Thanks so much, Tom, for the presentation. Agradecemos al conferencista, a Tom Van Dam, por acompañarnos el día de hoy y por compartirnos sus conocimientos respecto a este tema.
And Juan and Pilar, let
Listo.
people know that questions are good.
Yes. We have
If you're not
questions.
asking questions, then it is a bad presentation.
Yes, we have questions, but after that, we have to remember to our assistants some things. Queremos recordarles a nuestros participantes que para poder acceder a la constancia de asistencia es necesario se registren en el link que vamos a publicar en el chat y que a través del QR que están viendo en pantalla en este momento también pueden ingresar a él. Les vamos a dar unos momentos para que se registren si no lo han hecho. También para nosotros es muy importante saber qué tal les pareció la conferencia de hoy. En pantalla ustedes están viendo un QR y en el chat están viendo un link donde pueden evaluar qué tal les pareció la conferencia de hoy y también van a poder dejarnos los temas en los que están interesados para ver el próximo año. La grabación de esta conferencia va a quedar disponible en nuestro canal de YouTube la próxima semana y allí podrán ver y repetir este tema tan interesante. Les dejamos la información al finalizar la conferencia. También queremos agradecer a nuestros patrocinadores. Gracias a ellos estamos realizando este ciclo de conferencias. Ellos son Argos, SICA y Holcim. Bueno, y vamos a pasar a la sesión de preguntas, como les escribía en el chat. Las preguntas las pueden hacer en español, las transmitimos a nuestro conferencista en inglés y él nos les va a dar respuesta. Hoy nos está acompañando de con Juan Nicolás, quien va a hacer estas veces de traductor para nosotros y para él. Nicolás, bienvenido.
Hola Pilar, gracias.
Bueno, tenemos varias preguntas. Hay 3 preguntas, las 3 están en inglés, pero antes de esto yo las voy a transmitir en español para nuestros participantes. Entonces nos pregunta Javier Antonio Urbano, buenos días. Con respecto a la resiliencia en la costa, ¿cuál es el componente importante a considerar en la producción y el mantenimiento del asfalto? Javier Antonio Urbano nos dice, tell us, good morning, regarding resilience on the coast, which is the important component to consider in asphalt protection and maintenance.
Oh, I'm so sorry, Pilar. Can you say one
Okay.
more time?
Yes. Regarding resilience on the coast, which
Yes.
is the important component to consider in asphalt protection and maintenance?
So again, on the coast, and if you are in those low-lying areas that will be threatened by the rising sea level, and of course the magnitude of storms, and also we talked about river flooding near the coast. If you identify an asphalt pavement link as having being threatened by the flooding, the couple of things need to be done. I mean, one thing that we talked about was the concrete overlays. So just from a pure structural capacity consideration, an overlay of concrete over asphalt even a relatively thin layer of concrete, will really help protect that pavement. The other factors, though, might be if you have high velocity water flow. So if this is near a river, or if it's right on the coast where wave action is a consideration, there's going to be a larger effort that would need to be done with that, what they call is armoring. So there is to protect the embankments around the pavement to try to mitigate the impacts of erosion. Now, I'm mainly a concrete materials. Low carbon these days is mainly what I work in, low carbon concrete. But I've done a lot of pavement work. As a pavement designer, this is not so much what I would do, but this is what the drainage specialist and maybe the highway designer would do to armor. So put in certain types of protection along the embankment so that it would not erode. You would pave a shoulder that normally would not be paved to keep water from being able to get under the pavement and wash it away. So the two factors, just circling back, is one, ensure that the pavement structure itself is able to be resilient by using, I didn't mention this in my answer, but moisture insensitive materials beneath the asphalt. So stabilize with cement, stabilize the subgrade, stabilize the base. And the second part of that is possibly use concrete overlay. And then the third part is if you will have high velocity water flow, then you will need to armor the pavement itself through the embankment and the shoulders.
Thank you, Thomas. I'm going to translate your answer.
And you can summarize it very quickly, I think, into the key
Ok,
points.
ya. Bueno, lo que él contestó es que se identifican varias tendencias, pero hay unos actores claves que él quiere tener como recalcado. Primero, que se debe que asegurar que la estructura del pavimento sea resistente a la humedad y que sean materiales sensibles, pero que se estabilice la base. Segundo, utilizar concreto también, pues a todas estas partes que están cerca de la costa, que tengan problemas de tormentas, de river, se me va la palabra, sí, de agua cerca. Y tercero, agregar capas de refuerzo para mayor protección.
I
Okay.
think you were more succinct than I was.
We need you let a time for Nicholas to translate your answer. So,
Yes, I will.
okay, thank you. Andrés Peña nos dice, permítanme acá un momento. La climatología aquí en Colombia es realmente difícil. ¿Cómo podemos mejorar nuestros diseños en pavimentos de concreto? Climatology here in Colombia is really difficult. How can we improve our designs in concrete pavements?
And of course, I will have you repeat one more time. I think I understood, but
Okay,
one more time.
one more time. Climatology here in Colombia is really difficult. How can we improve our designs in concrete pavements?
There are several software tools available. So I don't know if you want to translate as I speak. Would that work, Juan, or not?
No, I prefer if you can talk
Okay.
everything. I'm
Yeah,
gonna
because
write
then you can
here something.
fine.
Yeah.
So there are software tools available that are offered by different individuals. So for example, if you go to the American Concrete Pavement Association, they have a tool called Pavement Designer, and it is available free online, so you can download it. I think if you use a tool such as that, it might be able to help with the design process, and it is something that that part of it is easy. Now, the harder part, so that would be for design. So if you want to translate for design, that's fine.
Bueno, vamos a ir cortando la respuesta a poco, pero bueno, hay varias herramientas disponibles para esta que se ofrece Y la gracia es que busquen si ingresan a Designer, que está disponible de forma gratuita y que la pueden descargar. Y que usar estas herramientas puede ayudar bastante a facilitar solo el proceso de diseño. You can continue.
Okay. And I'll ask you a question quickly. Do you do a lot of concrete pavement in Colombia or not so much?
Esta va para todos, que si nosotros hacemos mucho concreto de pavimento, pero yes, we do.
Okay. So if you have a healthy concrete pavement industry, now it is simply a matter of going to your agencies and convincing them that it is a very, very good choice for a resilient pavement. That it may, I don't know what the cost comparison is. It may cost a little bit more at first, but in the long run, you can demonstrate that the concrete pavement is, for many cases, a better choice in the long run. And the key then isn't one of technology, it's one of policy. So we just have to get the agencies to, we talk about an arrow, right? Like a bow and arrow. They have to have that arrow in their quiver in order to be able to allow concrete to be a fix for their network. So if they haven't considered it, you need to work on them to get them to consider it so that then the concrete has a chance to be used.
Thank you. So, si se tiene una industria del concreto sólido acá en Colombia, pues es mucho más fácil avanzar hacia los pavimentos resilientes. Entonces, al principio sí puede costar un poco, pero el pavimento de concreto pues siempre va a ser la mejor opción a largo plazo. Entonces, que es muy importante involucrar a todas las agencias, empresas y motivarlas a que se considere esta opción.
And hopefully I answered that question.
Y que espera haber respondido
La
su
pregunta.
pregunta.
Ok. Beatriz Hernández nos pregunta, ¿cuál sería el diseño desde el punto de vista de infraestructura sostenible de pavimentos rígidos para mitigar la erosión costera que se presenta en el Caribe colombiano? What would be designed from the perspective of sustainable infrastructure of rigid pavements to mitigate coastal erosion that occurs in the Colombian Caribbean?
So I think it was about coastal erosion, but I will have you just repeat it one more time,
Yes.
Pilar.
Okay. What would be designed from the perspective of sustainable infrastructure of rigid pavements to mitigate coastal erosion that occurs in the Colombian Caribbean?
That's a good
From
question.
from a sustainable infrastructure point of view, what kind of grid pavement design could help to reduce the impact of a coastal erosion in the Colombian Caribbean?
Yeah, I think, Juan, that might not be a question that I can answer because I do believe it's about coastal erosion,
Yeah.
and I know many things, but that I do not know.
Bueno, él dice que la pregunta está buena, pero que él no podría entender en este momento cómo hablarles de la coastal erosion porque no tienen la información completa para responderla.
Ok. Nos pregunta José Rogelio Arita. Él nos dice, dame un momento. ¿Tiene alguna experiencia usando concreto mezclado con ceniza? ¿Qué tan efectivo es el uso de ceniza para el diseño de la mezcla de concreto? Thomas, do you have any experience using concrete mixed with ash? How effective is using ash for concrete mix design?
I have lots of experience working with ash, and I think there are obviously coal ash, right, from burning coal at power plants, and then also ash from volcanoes to create a natural pozzolan. And both ashes can be used very, very effectively. And in my opinion, we should always be using some type of supplementary cementitious material with our Portland cement. I think we should be using almost always use blended cement. You know, Portland cement blended with a good supplementary cementitious material, such as coal ash, which is the combination of fly ash and bottom ash, as well as volcanic ash in the form of natural pozzolans. The key is, of course, to make sure that the ash is of high quality so that it has good pozzolanicity. Do you know that word, Juan? So it has to be a good pozzolan, and that is tested through the R3 protocols that have come from Europe that now we are using in the US and I think elsewhere. And then to, of course, use the right amount to enhance our long-term performance without compromising our ability to construct with it, our workability, and as well as our early age strength gain, because both of those can be affected by the use of these ashes. So how's that, Juan? Okay? I know a
It's
lot about
okay.
this topic.
It's okay. Bueno, entonces él dice que él conoce mucho de este tema, que tiene bastante experiencia trabajando con ceniza, incluir las volcánicas, y que de estos ambos tipos que él menciona en la presentación pueden utilizarse de manera bastante efectiva, especialmente cuando se mezcla con el cemento. Entonces él propone, como opinión personal, que se debería utilizar cemento mezclados con buenos materiales suplementarios como ceniza volcánica o otro tipo de cenizas, pero que la clave es asegurarse de que estas cenizas sean de alta calidad y que esté debidamente ensayada, por ejemplo, siguiendo normas europeas que ya están llegando a Estados Unidos, pero que por supuesto el objetivo es mejorar el desempeño sin comprometer la trabajabilidad del cemento ni la calidad constructiva de este, pero porque ambas se pueden ver afectadas.
Thanks, Tom. Nos pregunta Beatriz Hernández, ¿hay técnicas de innovación sostenibles en el mantenimiento de pavimentos rígidos? Tom, are there sustainable innovation techniques in rigid pavements maintenance?
Yes. Probably the number one maintenance technique is diamond grinding. And so if you are using concrete pavements and they were either constructed to be rough or they were become rough, but they still have good amount of life left in them, we should be diamond grinding them. If you know this technique, diamond grinding, to grind them very smooth, because a smooth pavement is not only more pleasant to the user, it also has an advantage in the vehicles use less fuel when driving on a smooth pavement. And so when you drive on a smooth pavement, you save a lot of gas or petrol, and you produce less CO2. So we have found that roughness, if we can keep our pavement smooth, the sustainability impact is very great and very positive.
Bueno, entonces nos vamos con la última pregunta. Nicolás, por favor, se la puedes
Listo.
hacer a Tom. Yo la voy a formular en español. Nos pregunta Hernán
Pero
Pineda.
contesto esta que acaba de
Ah,
decir.
ok, sí, perdóname, perdón.
Bueno, entonces él está diciendo que sí, que lo más probable, lo mejor mantenimiento es el tema de rectificado con diamante. No sé si acá se utiliza en Colombia, pero que está usando a que si la superficie es muy rigurosa, lo que va a hacer es que se mantenga suavemente y un pavimento liso es excelente tanto para los conductores como por la comodidad, pero también en cuanto a que gasta eh, menos combustible y esto pues genera menos huella de carbono. Entonces como que sí se habla de ambas comodidades y que este sería el mejor mantenimiento que estaría ayudando tanto al usuario que maneja como al medio ambiente. And Tom, this is going to be the last question that we are going to ask you.
Okay.
And
Eh, Vamos a formularla primero en español para que nuestros
ok.
asistentes la escuchen y luego la hacemos en inglés. Hernán Pineda nos dice qué diferencia sustancial se debe tener en cuenta en el diseño de pavimento en un país con estaciones y en otros sin estaciones. Listo, Nicolás, ya se la puedes formular.
Vale. Déjame un segundo. ¿Dónde está? Qué pena, es que no estaba ocupado mirando otra
No te
cosita acá.
preocupes, no te
Ya le
preocupes.
miro.
Te la repito, ¿qué diferencia sustancial se debe tener en cuenta en el diseño de pavimento en un país con estaciones o sin estaciones?
Okay. So, what sustainable difference should be taken into account in a pavement design between a country with season and one without it?
So a concrete with what?
Uh, Again, what sustainability difference should be taken into account in a pavement design between a country with seasons and one
Oh,
without?
with seasons.
With these seasons, yeah.
I think that all good pavement design methods, whether asphalt or concrete, have to recognize the climate. And so, if you look even at the United States, of course, where I live, it is going to start snowing here any day. But yet, it will remain very, very nice in Florida and Arizona and parts of Texas and California and even Las Vegas, Nevada. So I think that um, all pavement design methods have to recognize the not only the high temperatures but also the low temperatures, the dry areas versus the wet areas, and so that usually is um, a parameter that is always considered when you start. I will say it is much, much easier when you are in a place that does not have winter. So I think for Colombia, your life is easier that way than it is here because not only do we have the the cold and the snow and the ice, but we also have de-icers. And these chemical de-icers are very problematic to the concrete. And we have to do a lot of work to make our concrete durable. So without that, your life becomes much easier. And I think this is why you have more time to spend on the beach.
Bueno, entonces la respuesta es que el diseño de pavimentos debe tener siempre en cuenta que el clima local, por ejemplo, en Estados Unidos, al tener tantos niveles y muchos estados, hay unos que tienen siempre nieve, como está en este momento Thomas en Michigan, pero en Florida hace calor todo el año, entonces este diseño depende mucho de la temperatura y la sequedad que tenga el clima de cada uno y son parámetros claves que deben ser parte del proceso del diseño de cada uno. Y menciona que en países como Colombia, en realidad es mucho más fácil porque no tenemos invierno, pero pues porque el diseño no necesita lidiar con condiciones de congelamiento o deshielo y al final dice que pues tendríamos más tiempo para estar en la playa a comparación de ellos que tienen que estar con tantas condiciones de congelamiento o de deshielo.
Hey, I'm wearing wool right now.
Nicolás, una última pregunta desde YouTube. Nos pregunta Rodrigo Gras, nos dice qué piensa, le pregunta al conferencista que qué piensa sobre el concreto sumergido por un largo tiempo en agua con sal, como por ejemplo agua de mar. Entonces, Tom, what do you think about the concrete submerged long time in water with salt? For example, seawater.
Yes. Um, we even the Romans have concrete still in seawater in Rome from 2,000 years. So concrete can be designed to be placed in seawater and last for decades and even millennia. I think the use of ash that was discussed earlier is important because these supplementary cementitious materials, they help to bind chlorides and keep the chlorides away from the steel. And then the other part of that, of course, is the corrosion of the steel. So we have to have very good construction and very impermeable concrete. So there are, we do have to pay attention to certain chemistry of our cement, but concrete is an excellent alternative and can be made to be very, very durable in seawater.
Thank you, Thomas. Bueno, respondiendo a la pregunta, habla de que los romanos utilizaban concreto que ha durado por siglos e incluso milenios de más de 2000 años y que él cree que el uso de la ceniza es muy importante porque ayuda a mejorar la durabilidad, de reducir la corrosión del acero y de hacer el concreto un poco más impermeable. Pero que hoy en día, pues sé que tenemos que seguir prestando atención a estos mismos aspectos químicos para saber cuál es la mejor durabilidad para tener este concreto impermeable. I think that was the last question.
Oh, very good.
Final de tu presentación, Tomás. Muchísimas gracias por acompañarnos. Thank you very much, Thomas, for joining us and sharing your knowledge and start with us. Have a great and good day.
Bye, Thomas.
Thank you so much for having me.
Thank you.
Yep. Bye-bye.
Bye,
Bye.
Thomas.
Gracias, Nicolás, por apoyarnos en esta conferencia.
Vale, con gusto.
Bueno, y también aprovechamos para agradecer a nuestros patrocinadores. Ellos son Argos, Sica y Holcim. La próxima conferencia de este ciclo los vamos a invitar a nuestros próximos eventos. La próxima conferencia de este ciclo será el próximo martes 4 de noviembre. Nos acompañará el ingeniero Luis Fernando Boerques del Consejo Colombiano de Construcción Sostenible y él nos hablará sobre la certificación Envision, el nuevo estándar global para transformar la infraestructura pública en referente de sostenibilidad. Vamos a publicar en el chat el link de registro para que puedan registrarse si aún no lo han hecho o para que puedan compartirlo con sus colegas o personas interesadas en este tema. Bueno, y en 2026 tendremos la reunión del cemento y el concreto, el máximo evento de la construcción, el más esperado del sector de la construcción, la reunión del cemento y el concreto PROCEMCO 26. Se realizará en el Centro de Convenciones de Cartagena de Indias del 6 al 8 de mayo de 2026 para volvernos a reunir en este escenario de conocimiento, innovación y networking. Los invitamos a estar pendientes de sus correos, allí les estará llegando más información sobre este evento. Bueno, y gracias a quienes nos acompañaron por YouTube, los invito a suscribirse al canal y activar la campanita para no perderse de nuestras conferencias. La grabación del día de hoy estará disponible la próxima semana junto con más de 350 conferencias dictadas hasta el día de hoy. No se olviden, más de 300 conferencias sobre construcción e innovación. En redes sociales nos encuentran como Procemco, estamos en Facebook, LinkedIn, Instagram y ahora también en nuestro canal de WhatsApp. Nuestro agradecimiento especial al ingeniero Thomas Van Dam, a nuestros patrocinadores Argos, Sica y Holcim y por supuesto muchas gracias a todos ustedes por acompañarnos y ser parte de este espacio de formación. Los esperamos nuevamente el próximo martes con la última conferencia para ver cómo funciona la certificación Envision. Que tengan todos una feliz tarde.